Hello, hi. Today's new topic from the basic of electricity chapter. The topic name is Ohm's law. Before I Ohm's law, explain charge, potential difference, some electrical equipment like voltmeter, ammeter, and about some brief idea about conductor, semiconductor, and insulator. And today we will start Ohm's law. So before I starting Ohm's law, 5 to 6 minutes I will revise the potential difference concept and go to the main topic Ohm's law. Okay. Suppose it is a conductor and another conductor. I will explain the potential difference across two different terminals or a point. Suppose here 0 volt and here 5 volt. Yes or no? The same case here 0 volt, here 5 volt. In the sense of this is positive charge. Yes or no? The, and inside the conductor, you know what? 3 electron. Suppose it is a 3 electron. I will take two examples. Here the potential difference in the sense of either in a voltage, that terminating point voltage is 0 volt. And here the 5 volt. Inside the conductor, the 3 electron or electron charge is negative, here the positive. And when the two different charges, yeah, these similar charges between what? Attraction force. It is negative, it is positive. Attracts towards. Okay. What is the direction of electron? That in that case also the direction of electron in this direction attracted by the positive charge. Yes or no? I will explain in the previous lecture the current direction, the direction of positive charge, you can say, otherwise you can say the opposite to the electron direction. You suppose here the electron direction, that the current flow I in that direction. Similarly, you will here the current similar in way, here the electron direction in that, so the current direction is that. Suppose here potential difference how much? If you observe, what is here potential difference? 0 to 5 volt, here 0 to 50 volt. Suppose here the potential different 5 volt. When the potential difference across the conductor is 5 volt, in that condition I will assume the current is flow I and the value of current is I. But in this case, the potential difference at 50 volt compared to that, how much times? 10 times. So the current is always always, so sorry. So current is also increase. Why? Suppose I have a two but different level of water body. Suppose here the water inside this bucket 5 liter, then flow of speed of water is I in the sense of current. Suppose in another bucket here the 50 liter, then flow of water speed is what more compared to previous. Again repeat as so suppose this bucket the water filled here 5 liter. In that condition the flow of water speed, and another case when the here replace 5 liter 50 liter, then the flow of water speed are different or not different, because if more the water that same height, then speed of current any speed of flow of water are different. In the similar way, here the potential difference is 5, here the potential difference is 50. Conductor are same, conductor are same. So the value of current is also increase compared to that. Suppose here 10 times potential difference, so current is also increase 10 times. Yes or no? सपोज मेरे बॉडी में पहले थोड़ा सा हीट था, सपोज लो हीट, my field is less area. If my heat is increased, my field is also increased. Yes or no? In similarly way, the potential difference is 5 when the current value I, when the potential difference is increased, the value of current is also increased. Or the potential difference is increased first, then the value of current is also increase. Yes or no? Yes or no? The similar way you can define the Ohm's law. Ohm's law, what is say Ohm's law statement? Whenever a potential difference applied across a conductor, that after flowing current is proportional to the potential difference of that conductor according to Ohm's law. So here observe, yes or no? ओम्स लॉ क्या करता है, यही तो है ओम्स लॉ। क्या देखते हैं, लुक हियर, आई डायरेक्टली प्रोपोर्शनल, मैंने इन दो फिगर में क्या ऑब्जर्व किया कि पोटेंशियल डिफरेंस को बढ़ाने से करंट का भी वैल्यू इंक्रीज कर रहा है। यस सर, जैसे जैसे पोटेंशियल डिफरेंस बढ़ा रहे थे वैसे वैसे करंट का वैल्यू इंक्रीज करते जा रहा था। अब ओम्स लॉ का भी स्टेटमेंट यही है कि whenever a potential difference applied across a conductor या material, then that current will be flowing across the material is proportional to the potential difference. That's the Ohm's law. यही Ohm's law. But some book are written that which is right, which is wrong. I will explain. Suppose potential difference is 0, then in that condition current is flow, not flow, not. If a potential difference must be need for flowing the current, so the current depend upon the potential difference, not the potential difference depend upon the current. Yes or no? If you is the meaning here the current is increase, voltage and potential difference is also increase. Yeah, voltage is also increase. Yes or no? It's totally wrong, because for flowing the current must be potential difference are present. So the potential difference here cause, but it is a cause. It is a Effect. Yes or no? It is cause, it is effect. Here, if you consider effect here, cause here, the never effect depend upon the cause, so it is the wrong. Should not focus here. Always remember that if any book written here cannot satisfy the Ohm's law, not satisfy the flow of current condition across a conductor, across a material, and this law is valid for whole conductor, not a point out at a point of part of point of a conductor. Yeah, you can say a cross sectional area part of look like according to suppose it is a conductor. Yes or no? I will supply a potential difference across it. I will explain the current direction the same as the positive charge. So the current is flowing in that direction with potential difference name is V. This law is valid for all the material. This law is valid for whole material. Suppose if you find how much current across only that cross sectional area, you cannot explain that law. That law explain Ohm's other form. If in your syllabus is not given, so only your syllabus is given this law applicable applied for whole the conductor, not a piece across sectional area across. So come to point here, proportionality constant remove, then V, and V can also modified I into R is equal to V. Yeah, V is equal to IR. Yes or no? Ohm's law. What is the Ohm's law? When any potential difference apply across a conductor, then current will be flow across the conductor is proportionality to the potential difference across the conductor terminal. Yeah, end point. Simply at a constant temperature or any physical parameter are also remains constant like pressure, humidity, other things are also constant condition at what constant temperature. At constant temperature, when a potential difference applied across a conductor, then current will be flow, and that current is proportional to the applied potential difference. What is here I? Where I nothing but current SI unit एम्पियर इसको इंडिकेट करते हैं ए से V नथिंग बट voltage indicated by V1 by R is called conductance R resistance. Yes or no? From the Ohm's law come out, but I directly proportional the change in potential difference. So where this form is all the form are valid, but originally the law explained where that only, and I is the current flowing across the conductor, V the voltage applied across the conductor, resistance the resistance of the conductor. Resistance does not depend upon the voltage and current. Resistance depend upon the material. Resistance does not depend upon the voltage and current according to experimental. But here in formula, is considered, but not really the considered in the experimentally. So I will explain now um, uh, the graph between voltage and current. Suppose again I will take 10 volt here 50. If you take 150, 10 volt plus this current value is I. Suppose here 0 volt and then increase the potential difference here 20 volt again here 0 volt plus here the how much 40 volt and here 0 volt plus 80 volt. I will explain before now when the potential difference are here the potential difference change in voltage is equal to 10 in this case change in voltage 20 in this case change in voltage 40 in this case change in voltage for 80. If you observe this all the four are same types of conductor, yes, made of same material, so the all have the resistivity value if you consider the same, but experimentally here eliminate. Observe when the voltage, if you explain when the our one bucket have a here 10 liter then flow of a speed suppose I. Now when the 10 liter replaced by 20 liter then speed of water will be increased how much times 2 times. So here 2I after 20 replace 40 compared to the first how much 4 times, then current will also flow 4 times. So here 4I here 80 volt yani if we assume it is not a 80 liter water compared to first 10 liter water how much times 8 times increase. The same way when the water level is increased water volume is increased the flow of water in sense of current in this also increase how much times 8 times, yes or no. Suppose I will draw a graph what suppose I draw the graph between voltage and current. It is a V axis, it is a current axis, it is a volt. Suppose I will here 0, here the 10 volt, 20 volt, 40 volt, here the 50 volt. Yes or no? And that in the case of 10 volt, the current will flow across the conductor is I. Suppose here I, here 2I, here 4I, here 8I. And draw the graph. When the potential difference is 10 volt, the current flow across the conductor potential difference is 20 volt, then the current across the conductor is 2I. When the potential difference is 40 volt, the current across the conductor is 4I. When the potential difference across conductor is 80 volt, then current flow across the conductor is 8I. यानी linearly way या directly both increase. So if you draw the graph, yes or no, and that value is slope value. It is a slope. It is the value of what? It is what is called here slope, the resistance. So the graph between voltage and current linearly, because the law also explain when the potential difference increase, in that ratio current is also increase. Yes or no? Now the question here arises: what is the R? What is the physical formula of the R? But you can also find from the numerically value here the proof of V is equal to I, or the R is equal to V by I. If you look here, if you can say the resistance depend upon the potential difference here voltage, but is not really. It's only for numerically, not experimentally. Resistance depend upon the voltage या current. Resistance independent the value of voltage and current according to Ohm's law. Ohms ने यही प्रूव किया था. इस proportionality constant 1 by R होता है. Some book written 1 R because it is taken V directly proportional to I. The V is equal to IR. 1 by R is conductance, R is the resistance. But your question arises, what is the resistance? Resistance is nothing but an obstacle. Obstacle क्या है? Suppose यहाँ पर बहुत ऊंचा डैम है, ऐसा या पहाड़ पर से नदियां आ रही है, या कुछ भी छोड़ो उसको छोड़ो, वाटर टंकी है, यस और नो, और एक नीचे पाइप से जुड़ा. अगर बीच में हम पाइप को कोई चीज से ऑब्स्टेकल पैदा करते हैं या एक बल्ब लगा कर ऑब्स्टेकल पैदा करते हैं, तो बल्ब को अगर स्लो कर देंगे, थोड़ा कम खोलेंगे, तो हमारे जो नीचे वाले बर्तन हो गया, नीचे वाले जो डेस्टिनेशन है वहां पर पानी कम है. जो ही बल्ब को ज्यादा खोल देंगे तो उस केस में पानी हाई स्पीड से आता है. क्यों? तो वहाँ पर ऑब्स्टेकल, वहाँ फ्लो ऑफ वाटर को जो रेजिस्ट करने वाला होता है, अपोज करने वाला होता है, वो कम होता है. The resistance is nothing but resist the flow of current in a circuit, in a closed circuit. Yes or no? Resistance is nothing but resist the flow of current, called resistance. Resistance not depend upon the voltage and current. It is the metallic property. Different matter have different resistance value. Yes or no? Silver less value because silver is high conductivity of electricity compared to gold. Some body say if you both option then you take the gold. Not gold resistance is very high compared to high silver. So silver conductivity is less. So the gold conductivity is less compared to silver. So I explain about some brief out what resistance. Come here. What is the resistance? Suppose it is a conductor. Yes or no? Conductor having contains length. I'll be इसमें से छोटा सा पार्ट काट लेते हैं. ठीक है, ये हो गया क्रॉस सेक्शनल एरिया. इसको क्या बोलते हैं? क्रॉस सेक्शनल एरिया, इसको आप ए से इंडिकेट करते हैं, ये क्या है? Simply you can hear A, yes or no. The physical formula of R is nothing but R is equal to rho L by A. Here the rho is the resistivity या conductivity. Rho is the resistivity. What's the resistivity या specific resistance. L, what real? Length of conductor A cross sectional area. If you ask somebody the resistance depend upon voltage, you can say no. Current, you can say no. The resistance depend upon what? The cross sectional area of the conductor या material, length of conductor या material, resistivity या specific resistance. Resistivity is a property of also metallic. different metal different होता है. Yes or no? So comes also the resistance value. Different material have different, but resistance also different. L A. Suppose how the resistance specific resistivity depend only metal. Suppose it is a one piece of it is a silver. ये सिल्वर है आपका, सिल्वर है. सपोज ये लेंथ L है, ये लेंथ 2L है और ये पूरी लेंथ 3L है. अगर आपसे पूछा जाए कि इसमें किसका रेजिस्टिविटी कितना होगा, इस वाले कंडक्टर के टुकड़ा का या इस पीस ऑफ कंडक्टर का या ये पीस ऑफ कंडक्टर का, यहाँ पे लेंथ इंक्रीज कर रहा है. इस केस में सिल्वर इतना बड़ा है, इसमें इतना बड़ा, इसमें इतना बड़ा है. तो क्या लेंथ के इंक्रीज करने से कंडक्टर या मटेरियल का रेजिस्टिविटी इंक्रीज करेगा? यू कैन से नेवर, बिकॉज रेजिस्टिविटी डिपेंड ओनली द मेटेलिक property, is a concentration property. Yes or no? It is a metallic property. If you how much long increase, but does not affect the resistivity. Suppose it is silver. If you cut here, also this small part of resistivity same as a long part. Resistivity does not depend upon the part, length, cross sectional area, any. But resistance depend of length. Here suppose R is equal to rho L by A. All are the cross sectional area same consider. Here R value what? Rho, what is the L? 2L. Suppose R dash by A. Here rho, what is the L value? 3L by A. Yes or no? If we modified here, the rho L by A into 2 R double dash rho L by A into 3. The R dash, what is the value of R? 2R. R dash is equal to 3. Here you observe when the increase the length of resistance, the value of when the increase the length of sorry not resistance when the increase the length of material या conductor in that case resistance value also increase same way. One thing now I modified the all figure. Yeah, again suppose suppose all the same material like ये सिल्वर है सभी क्या है सिल्वर है सभी का लेंथ समान है बट क्रॉस सेक्शनल एरिया आर डिफरेंट सपोज हियर द क्रॉस सेक्शनल एरिया here the cross sectional area is 2a here the cross sectional area is 3 then in that case the resistance value how much suppose r is equal to rho l by a because the resistivity all the cases are same because all the figure are made from same material like a silver so the resistivity of all are same length are same in that case r inversely proportional to the a suppose we have the r dash how much r dash rho l by 2a r double dash rho l by 3a yes or no here the how much resistivity constant e also constant so r dash directly proportional to by 2a here the resistivity in the all the cases are same and which taken the length is also same so the r double dash directly yeah inversely proportional 1 by root 3 if you observe when the cross sectional area are increased the resistance value are decreased and the cross sectional area is increased the resistance value are decreased yes or no so the come to the main point if you learn or not yes yes or no is equal to r directly proportional to l r inversely proportional to the cross sectional area if you consider same material r does not depend on it if you change the material then r also depend the resistivity because different material have different resistivity value yes or no one thing another suppose it is a thin wire thick wire another problem thin thick and short it is thin wire it is a thick wire it is a short wire it is a long wire. Here the resistance value what? Maximum, yeah, minimum. Compare to both, who is maximum? Here thin wire, the cross sectional area less. Here R is equal to rho L by A. Suppose both are same length. In this case, length same. Now problem A or B, length are same, but one wire बहुत पतला है, एक मोटा है. Thin one पतला, thick one मोटा. In that case, when the wire is thin, then cross section is also less. Resistivity, the metallic property. When the thin wire, the cross sectional area decrease, the resistance is increase. But here the thick wire, rho LA, how can suppose it is a headphone. Suppose this. What is the cross sectional area? Very small. But what is the cross sectional area of this marker? It is high. In the cross sectional area is less, the resistance is increased. When the cross sectional area is high, in that case, resistance is decreased. Come to the C and D also. Here R is equal to rho L by A. Here short, here rho L by A. The long means the length of wire is increased. When the length of wire is increased, the resistance is increased. Short means when the wire of length is decreased, then resistance value is decreased. It is the physical formula of a resistance, but resistance also depend on the temperature. Yes or no? Because I will explain the first class. The conductor have a positive temperature coefficient, in the sense positive temperature. When the temperature is increased, as well as that resistance value is also increased. Yes or no? So R1 is equal to R0 1 plus alpha delta. Here the R0, the resistance value of conductor at 0 degree temperature. This is the resistance value at, suppose, temperature at T1. टेम्परेचर एट T1. सपोज ये 0 डिग्री पर था, ये 20 डिग्री पर है. जैसे ही टेम्परेचर बढ़ा, रेजिस्टेंस का वैल्यू भी बढ़ गया. सेम वे also resistivity depend upon what? Temperature. So the resistivity and resistance both have the metallic property and both depend upon the temperature, and both in the case positive temperature. In the sense positive temperature ने टेम्परेचर के बढ़ने से इसकी रेजिस्टेंस या रेजिस्टिविटी की वैल्यू भी बढ़ जाती है. ओके, ओम्स लॉ क्या एक्सप्लेन करता है? देखिए कि I directly proportional to rotational difference, and if you modified it, that comes the V is equal to IR. R where resistance SI unit, ohms सिंबल ये होता है. ये क्या है? यहाँ करंट है. V क्या है? वोल्टेज है. इसका SI यूनिट एम्पियर, इसका SI यूनिट वोल्ट. Yes or no? 1 by R is equal to also no G is called a Simon SI unit या ohm inverse. The Ohm's law valid for only a one direction flow of current, yani linear circuit, not a linear circuit, not a semiconductor, yes or no, not a transistor, just like. So, will be some question related to Ohm's law, yes or no. A specific resistance of wire depend on problem number one. Specific resistance of wire depends on option A. What is given? Length. Option 2, area in the sense of cross sectional area. Option 4, 3, dimension. And option 4, metallic material. A specific resistance, nothing but resistivity. Resistivity is a property of metal. Different metal have different resistivity. So it is not depend upon the length. I will explain before. Not depend upon the cross sectional area. Not dependent dimensional. It is a depend on material. Second problem. Resistance depend. What is given? The resistance of a straight conductor. Resistance of straight conductor depend on option A, temperature, though material in cross sectional. चौथा shape. Here the resistance of a straight conductor is depend upon, according to Ohm's law, the temperature is constant, so that does not depend temperature. For somebody have doubt, you written R is equal to rho L by A. But here the written a straight conductor. It means do not change the length. Yes or no? Do not vary the temperature, and all the physical parameters are the constant. In that case, it is also depend upon the material. Yes or no? So the resistivity and resistance both are depend on metallic property of the conductor. One problem. What is the given? Resistance of material. Resistance of material 2 meter long and a cross sectional area 2 meter square 1.6 गुने 10 to power minus 8 ohm. Find the specific or the specific resistance. Option A. Option A here, right? Option A 1.6 minus ohm meter second 6.4 into 10 ohm meter third 3.10 into 8 ohm meter and fourth ohm meter. What is the given in this question? If we read resistance of material 2 meter long and cross sectional area इतना resistance value इतना तो find the specific resistance. I will explain a specific resistance nothing but resistivity a given what length 2 meter cross sectional area 2 meter square the value of R 1.6 गुने 10 to power 8 meter. Then what is the resistivity? You know that what R is equal to rho L by A. Put the all parameter in this equation and you will find the easily resistivity value. What is the given the R? 1.6 गुने 10 to power minus not meter ohm and the resistivity not given. L is given 2 meter cross sectional area is 2 meter square. Yes or no? Meter to meter cancel 2 to 2 cancel. The resistivity ohm. Which option is matchable? Option number first. Yes or no? Yes. Now on the ribbon here present or not?